Hello statistics student, this video is for chapter 9.5 full hypothesis test for mean. So we'll concentrate on looking at how we can do a hypothesis test if we're testing population mean using a sample. Now the main idea of why we can test it is because X bar sample mean is normally distributed by the mean value theorem. Well, they are usually not normally distributed, but under some circumstances they are. And the criteria or the condition is if we have a central limit of theorem apply, right? Central limit theorem say if sample size is greater than 30 or X is normal, if your original distribution is normal, sometimes we don't have it, but sometimes we do, then X bar is normal. And if it's normally distributed, we can tell if we have a particular, rare sample. So, assuming that mu, which is from x0, the x0 mean is here, and then you can evaluate where your x bar is. Is my x bar here, or is x bar very, very rare, or is it not rare? So it would tell us if I can apply the rare event rule that I have a surprisingly significant X bar. So now it is really based on the null hypothesis. And the reason why we can calculate the p-value, which tell me how surprising X bar is or sample size is because of the central limit theorem. So it's essential that this sample that you collect is normally distributed. And most of the time they are if you have a large sample size. What about if I have a small sample size and I don't know what if X is normally distributed? Sometimes they tell you it is. But if not, then you can use the normal quantile plot to do an assessment of whether this sample is from a normal distribution. So before we do the full hypothesis test, so this is the theory behind. And before we do the whole thing, let's review some terms. Population mean is mu. This is where we want to do our claim. Our claim is always about population parameter. A sample mean is X bar, everybody knows. Sample standard deviation is S. This is based from the sample. Sample size is N. So this is what you always have from a sample. Now, occasionally you would have sigma. If you have sigma, then you can use Z normal to do your distribution. If you do not know sigma, unknown, then you use t distribution, just like what we have in the confidence interval. So when we do a hypothesis test for mean, you do have to think carefully if you're using t or z. In a lot of software, you actually have to determine that before you use your software. But instead, this is a little easier because even if it is the same program for T or Z. You just decided whether you provide sigma or not. And then of course significant level is alpha. You can change it yourself depending on if you want a higher or lower one. It is the probability of what is known as unlikely. So I go through the steps. So it's the same as the proportion. We have 1, 2, 3, 4, 5, 6, 7. No, 5, 6. 6 steps. The first two are what you have familiarized with. The first one is to collect all the information and write the claim, as well as the alternative hypothesis in symbolic form. If you have, the only difference from proportion is you could have sample data. Instead of X and N, you would actually have individual data. In that case, you enter it in the sample editor. So you would go to StatDis and enter your data like in a column. So later on, I'm going to do an example with sample data. That's why I have something here. Then you will identify what types of tests that you have, just like before, left tail, right tails, or two-tailed tests based on the arrows, or whether it's not zero in the alternative hypothesis. And then you would have to decide whether you use T or Z distribution. Here is spelled it out. If sigma is known, you use Z. Your tick mark, that means your standard deviation tick marks are based on Z. If your sigma is not given, then your tick mark is based on T. And T is how far away the X is from S over, from the mean, the given X0 mean, over S over square root N. Okay, so you do not have sigma over square root n, you use s over square root n. The tick mark, each tick mark length, standard error is modeled by t. Okay, so use the after you have your sample, the one that you use to calculate p-value and z or t statistics is under this hypothesis test. So I'm going to show you a little bit analysis, hypothesis testing. You could see mean one sample. This is where you calculate it. So if you have a summary statistic, you do that. You can fill in the alternative hypothesis, fill in all the summary statistics, including sigma if you have. If you don't, then you leave it blank. Or if you have data itself, then you put it here, and you don't have that many to enter. All you need to do is talk about the claimed mean and also the alternative hypothesis, and you do evaluate. You would calculate the required p-values and t or z statistic. And then, of course, the last two steps is about conclusion about X0 based on your p-value. If p-value is less than or equal to alpha, you reject X0. You have a significant sample. And if not, if your p-value is large, that means it's agree with your null hypothesis, then you say fail to reject X0. Exactly the same as in proportion. Then you do a conclusion about the claim, which is whether you have sufficient evidence or not sufficient evidence to either reject the claim or support the claim. Again, you can also use the flowchart if you don't want to. Okay, so this is exactly the same as what you have proportion, except in the middle. Okay, and what about conditions? So can I just collect something and then always just go through the hypothesis test and do some conclusion? So no, the two conditions that you have is you have a simple random sample. It has to be independently collected, and also the population is normally distributed or n is greater than 30. So you have to have a okay sample size. And if you are not sure if your population is normally distributed and you have a less than 30 sample size, you should use a normal quantile plot to check if the data is normal. If the data given is normal. Okay, so do the first example. We want to test the claim that mean amount of adult sleep is less than 7 hours. So what is the best way to do that is we collect a sample of 12 adults where the X bar is, and we find X bar and also S, and we use a significant level of 0.05 to test this claim. Now, in order to do that, we have a really small sample size. Oh, but it's lucky that we know hours of sleep actually abnormally distributed. So we don't have to worry that it is obey the central limit theorem. So the first thing is to write the claim because you're claiming that it is less than 7. So you write it down. And then your null hypothesis would be equal because your accepted fact or the one that you want to challenge is it could be equal or greater than 7. So you use the minimum one to challenge yourself. And this is the claim. So the claim is in the HA, which is the alternative hypothesis. If this work out, you would able to support it. Remember, when the claim is in the alternative, you can support the claim if you have a low p-value. So, and then the other things we want to say is what types of tests we have. We want it to be small in order for this to work. So it is a left tail test, and we use the t distribution because sigma is not given. So nowhere is there we have sigma. We only have X bar and S. To do it, so we will write it down. We write down the 6.82. S is 1.99, N is 12, and we're claiming that less than 7. So let's go over on this side and use here. So maybe I'll start from the beginning. I'll say it should be analysis, hypothesis test, sample, mean one sample, and we are doing a less than. Is it a less than? Yes, we're doing less than 7. The significant is it 0.05? Yeah, 0.05. Our sample mean is, our claim mean is less than 7, less than 7. We don't have sigma. Our sample size is 12, really small. Our mean is, forgot, 6.82. 6.82, and our standard deviation is 1.99. So this is from, these three are from the sample, and then we are ready to evaluate, double check the alternative is right. That's the most important thing. And then we have a t. So see how clever it is. It knows that if you don't have sigma, it's going to use t to do it. So t is negative 0.99. P-value is 0.1819. Less than 6.82. Maybe I have a wrong number here. So maybe I forgot to, let's check if I have some wrong number or not. 1.99, 6.82, and so yeah, I less than. So I think the one that I typed here is wrong, so I should change it. So let's correct it. T is negative 0.99, so let's change it. Negative 0.99. I think it doesn't change the 0.1619. 0.1619. Maybe I have a typo. 6.82. Maybe I put in 6.28 or something. Oh no, my sample size, I write 120. It should be 12. Yes, so that is right. T is negative 0.31. That's right. So I don't have a mistake. I just entered something wrong. So it is important that you double check carefully. So we get that. You can see that the p-value is not very small. It's not a surprising sample, and is very close to the mean. It's only below the mean for a little bit of 7 hours. So we say p-value is greater than 0.05, fail to reject 0, and it's not a surprising sample. So we say there's not sufficient evidence to support the claim that it is less than 7 hours. We use the word support because our claim is at the A is the claim. So your wording would always say support. If you use a flow chart, we'll see that it is box number 4. Why? Because X0 is the claim and we fail to reject 0 is box number 4. Again, it's not sufficient evidence to support the claim. The claim is not correct. So here, no, this one. No, this one. Okay, so other inference. So they say public health guideline for hours of sleep per night is 7 hours or more. Now, does it follow the guideline? So we say we cannot support this. It's not less than 7 hours, so it could actually be 7 or more, right? The result concluded the mean stays at not less than, but possible to be 7 hours or more. So yeah, so does the public do follow the guideline? So I have another example that use data. So, but I think I only have 2 minutes left until 15 minutes. So I'm going to use another video to do example 2.